Hello, my name is Michael Shelton, and my technical advisor is Dr. Jose Macedo. And the project that I've been working on is designing and hopefully implementing a 2-axis servo motor demo. I'm going to go through the agenda with you guys. First, we're going to start out talking about the background. Then we'll go into the problem statement so you have an idea of what I'm trying to solve. Then we'll discuss the goals, the potential solutions, and lastly, we'll wrap it up with the future focus for next quarter. So the background, the IME 356 class is specifically automation manufacturing class, and it is the class that mostly utilizes the automation lab to work on a variety of projects, and they focus on programming the various automation equipment that is contained within the lab, so that way they can test their skills and actually see the end result of their programming in action. The lab has been recently renovated thanks to some very generous sponsors, and one of the key renovations was a multi-axis servo drive, and that's going to be what I'm going to be focusing on for my senior project. So I'm going to read for you guys my problem statement. The IME 356 class needs a 2-axis demonstration in order to verify that the students have correctly programmed their servo drive while incorporating the machine vision software. So if you're not familiar with the machine vision software, it's simply just a camera that overlooks the process, and that's something that they have to program as well. The goals for this is I want to provide a feasible solution for this demo that maximizes efficiency as well as the lifespan, and along with that I want to minimize the cost, noise, and maintenance, so hopefully once I implement it there won't have to be much maintenance involved and it'll just run properly from here on out. I looked at several solutions, the first one being screws. The 2 screws I looked at was a lead screw and a ball screw. After some research I found that they had some fairly similar benefits, however the ball screw was substantially more expensive, so I decided to eliminate that option and just focus on lead screws as far as screws are concerned. The pros for lead screws are they're fairly accurate thanks to the fine thread that are contained in the screws. They're low cost and low maintenance. Usually with screws you have to provide some sort of lubricant. However, with the lead screw you do not. Because they are a little bit slower, it's a little bit easier to maintain. They're also durable and flexible, and that's thanks to the wide variety of thread, and also they're quiet. One of the drawbacks, as I mentioned with the low maintenance, is that it is a slow speed, and that's just due to the distance per revolution. However, we might find that with the certain applications that students will be using, the speed might not be an issue. The other option is a belt, and this also has a wide variety of pros as well as cons. The belt's very repeatable. Once you kind of get it going, you know what to expect. It's efficient. Unlike the screw, it does have very fast speeds, and it is relatively quiet. Some of the drawbacks is it's easily worn down, and that's something I read in several case studies through companies. It does require a fair amount of maintenance. You actually do have to have someone come in and retighten the belt, and if it's not tightened properly, then the belt can be torn and it would have to be replaced. And also it's fairly difficult to select a belt type. Belt type is dependent on the speed and the application as well as the motor. So for different applications you might have to get different belts, and that can cause a bit of a headache. So after looking at these two, I discovered that the lead screw might be a better option, simply because it is more durable and it fits more of the criteria. Here's a quick video of a linear motion lead screw. This is only one axis, however the solution that we will be providing will have 2 axes, so it'll be similar to that, and it'll just sit right on top of that railing system, so that way they can go in both an X and Y direction. So I lastly want to wrap it up with my future goals for next quarter. So from here on out I want to qualify exact materials and exact costs. I've already decided, like I mentioned, that the lead screw will be best. However, I want to look at different brands and shop around for the best costs. so I can create a bill of materials to move forward. I also want to create a specific application so the students aren't just watching the rails go in two directions. Instead, I can create some sort of game to make things a little bit more interesting and entertaining, so they have something to look forward to when programming. The last thing, I will use the bill of materials to purchase and assemble the parts and hopefully be implemented into the automation lab. I would like to thank you guys for taking the time to listen, and I encourage you guys to leave any feedback that you think will be helpful. Have a good one.